Assalamualaikum and very good day to everyone. Today, our group is going to present a topic that is not only fundamental in mathematics, but also highly useful in real life, which is the application of linear algebra. Specifically, we will focus on how the Gaussian elimination method can be used in daily life, such as in determining the ratio of ingredient when baking a cake. Before we go deeper into the application, it is important to first understand some basic definition. Linear algebra is a branch of mathematics that deal with vector space, and system of linear equation. It provides powerful tools for solving problems where there are multiple variables and constraints. One of the most commonly used technique is linear algebra is the Gaussian elimination method. This method is a systematic way of solving system of linear equation. It involves performing a series of operations on the equation to simplify them into a form that make it easier to find the solution by mastering this method. We can solve problem efficiently whether they involve business, calculation, scientific analysis, or as we will show, baking a cake.
Okay guys, for the introduction of our case study, I'll be the one to explain it to you guys. Okay, there's a Fatima who is a worker at Iban Bakery. Fatima need to make a 3 type of cake, which is oat cake, chocolate cake, and black and white cake. Therefore, she will need to use a 4 main ingredient for all of this cake. This is the proportion for the following cake. The first one is oat cake, which is she need to use 21 pound of chocolate, 15 gallon of milk, 3 doses of milk extract, and 6 pound of flour. For the second one, which is chocolate cake, she will need to use a 9 pound of chocolate, 6 gallon of milk, 6 doses of milk extract, and 12 pound of flour.
Hi, my name is Muhammad Rizkan Siddiq, and today I want to talk about purpose of study in this assignment. So, first, it is to help Fatima find the total of each type of 3 different cakes that can be produced by using a constant ratio of 4 different ingredients. Second, it is to find matrix from the linear equation in form of augmented matrix. Third, to find answer for problem statement by using Gaussian elimination method. And lastly, it is to optimize ingredient usage to prevent the ingredient and cost of the ingredient from being waste. Moving on to the methodology, so as you can already know, we use Gaussian elimination method. So how to do it? First, we recognize system of linear equation such as x1 plus x2 plus x3 equal d1. We can use x or other variables such as x, y, or z, but in this slide we use x1 plus x2 plus x3 equal d1. So we need to find 3 linear equation. So x1 x2 plus x3 equals d2, and x1 plus x2 plus x3 is equal d3. As for the next step, we have to convert the linear equation to the augmented matrix in the form of A and B. So as you can see in the slide, that is the augmented matrix. So the third step of Gaussian elimination is to transform a system of augmented matrix that we do in the second step into a row echelon form, or REF. So the last step of Gaussian elimination is using a back substitution. So in row 1, the equation is x1 plus x2 plus x3 equal to d1, transform into x1 equal d1 minus x2 minus x3. We have to single the x1 to get the result, and row 2 we have to single x2. So x2 plus x3 equal to d2, transform into x2 equal d2 minus x3, and row 3 is x3 equal to d3 because x1 and x2 is 0.
Now I will explain about the solution. First step, we transform the information that we get from the problem statement into the equation and the augmented matrix. Okay, next step is we solve the matrix using Gaussian elimination method. So on the first row, that is not leading one, so we will reduce it and become leading one. So we perform a 1 over 21 R1 and will become the new R1. So we will get 3 over 7, 4 over 7 and 67 over 7. So after that, we reduce the non-zero constant at the second row, third row and fourth row. So on the second row, we perform R2 minus 15 R1 and become the new R2. So we will get negative 3 over 7, 3 over 7 and 3 over 7. The third row will do R3 minus 3 R1 and become R3. So we get 0, 33 over 7, 51 over 7 and 471 over 7. So on the fourth row, we do R4 minus 6 R1 and become the new R4. And after that, we reduce the second row, become a leading one. So we perform a negative 7 over 3 onto the row 2 and we become the new R2 and we will get 0, 1, negative 1 and 1. So after that, we reduce the non-zero constant in the second row on the third row and fourth row. So we use R3 minus 33 over 7 R2 and will become the new R3. On the fourth row, we use R4 minus 66 over 7 R2 and will become R4. And next we will reduce the third row to become a leading one. We use 1 over 12 R3 and will become R3, and after that we reduce the fourth row to become a leading one. So we use R4 minus 24 R3 become the new R4 and we will get 0, 0, 0, 0. Okay, for the third step and the last step is we solve the problem statement. So we will let A be the oat cake, B the chocolate cake and C black and white cake. So from the augmented matrix that we get before, we will get A equal to 67 over 7 minus 3 over 7 B minus 4 over 7 C, and B equal to negative 1 plus C and C equal to 6. So we substitute the C equal to 6 into the equation B. So B equal to negative 1 plus 6 and we will get B equal to 5. And next is substitute the 6 equals C equal to 6 and B equal to 5 into the equation A, and A equals 67 over 7 minus 3 over 7 times with 5 and minus 4 over 7 times with 6, and we will get 67 over 7 minus 15 over 7 minus 24 over 7, and A we will get 4. So the oat cake that represent A become 4, chocolate cake we get 5, and black and white cake we get 6.
As for the conclusion, in real life, the Gaussian elimination method plays a vital role in solving practical problems that involve multiple variables and equations. It is widely used in fields such as engineering, physics, computer science, and economics to model and solve complex systems, such as electrical circuit analysis, structural engineering problems, and optimization tasks. In essence, Gaussian elimination bridges mathematical theory and practical application, enabling us to solve real-life challenges that depends on linear relationship between variables.